literature claims noise is a plague of modern society, and it is to fight that plague that I, Vidita Nayak,
and I, Arav Vivek Shah,
are here to present a solution for noise pollution.
Noise pollution can be defined as any disturbing or unwanted noise that affects or deteriorates human or animal life. To find out if other people were affected by noise, we conducted a survey that assessed 600 people. Out of these, 78% of them said that noise was a hindrance in their lives. Out of these people, 94% of them said that they would gladly use a solution if provided with one. With these results, it became clear to us that action was vital.
Research has also shown that prolonged exposure to noise pollution can lead to headache, insomnia, and loss of concentration, which ultimately leads to reduced work ability and permanent hearing impairment. We used our school's design thinking process, RISE, reflect, ideate, sustain, and express to come up with a solution. We decided to use recycled rubber noise barriers. Noise barriers can be defined as a certain sound obstacle between the sound source and the observer. They block the direct path of the sound waves by absorbing some of them and reflecting some of them, thus reducing the amount of noise that reaches the observer.
There are many materials conventionally used for making noise barriers, but they come with their own cons. For example, metal is prone to corrosion, plastic has low structural integrity, foliage needs maintenance, concrete is expensive, and glass can break easily. Thus, recycled rubber becomes the ideal solution, though it has cons like odor and releasing toxic fumes if it catches fire. But as we plan to use this in open areas, the smell can be warded off. And rubber has a higher ignition temperature, so it can't catch fire easily.
There are also numerous good effects of using rubber. Rubber at present is used for its acoustic properties in indoor areas. Thus, it follows that recycled rubber would also be effective in reducing the noise. Recycled rubber is sustainable and eco-friendly. Rubber is comparatively cheaper to the other materials used to make noise barriers. Recycled rubber is even cheaper. Thus, recycled rubber becomes the perfect solution. Now, we will demonstrate the effectiveness of recycled rubber with the experiment. The setup of our experiment has a road and a house. The road is acting as the producer of noise and the house is the observer. We have two phones. Phone 1, which is the emitter of noise. We will be using white noise, which will act as a substitute for traffic. And phone 2 will act as the recorder of noise. Now, finding the average value of noise produced requires testing over an 8-hour period. So instead, we have downloaded an app that finds the average value of noise through LEQ or LAEQ, which is a value that gives approximately equal average values as it would have done over an 8-hour period. We have 3 types of rubber, rubber type A, B and C, which we will insert into these slots. Air is a very good insulator of sound because sound is basically vibration of molecules, and because air has fewer molecules than solids or liquids, it acts as a good insulator. Therefore, we will be keeping air pockets between the 2 sheets of the rubber. We will be measuring the sound for 15 seconds. First, we will have a control reading where we will measure the amount of sound if there was nothing in place to stop the noise from reaching the house.
3, 2, 1. 74 decibels. The minimum is 58 decibels and the average is 72.9 decibels. Now we will test it with rubber type A. Rubber type A is made from the crumb rubber of waste tires. The maximum is 73 decibels. The minimum is 56 decibels and the average is 67.8 decibels. Now we will test it with rubber type B. Rubber type B is made from the devulcanized rubber crumbs. The maximum is 70 decibels, the minimum is 58 decibels and the average is 68 decibels. Three, two, one. The maximum is 71 decibels. The minimum is 64 decibels and the average is 67.2 decibels.
Therefore, our experimentation has shown that the most efficient type of rubber is rubber type C because it is showing a difference of 5.5 decibels. This might seem like a small amount, but because decibels are measured on a logarithmic scale, when upscaled, this will make a huge reduction in the amount of noise reaching the observer. In a nutshell, our project sustainably, economically and effectively reduces the amount of noise pollution. Thank you.